So today I'll be talking about the combined spectral problems using the IR spectrum, the C13 NMR spectrum, and the H1 NMR spectrum. I am group 13. So I was provided with 3 different tables and a formula, C10H12O. And from these tables, I would figure out exactly what my proposed structure was and whether or not this formula was correct. So starting off, I used all the tables that were included in my worksheets to figure out what my proposed structure was. So beginning with the IR spectrum or spectra, the first thing that I like to do here is I'll draw a line at the 1500, just because everything before that, it has to do with the fingerprint region. We have some numbers here, 1400 to 1450, which is the CC/CO bend, and then some at 1100, which is the CC stretch. But everything over here kind of just blends in with the fingerprint region, so I don't really pay attention to that. The biggest takeaway from this table though was this big spike right here, which is the C00, which showed me that basically I had a carbonyl carbon, which is a C00 bond, and then some CH stretching on this end. Next, from there, I did the C13 NMR spectrum, and I used this paper to help me figure out what my structure was going to be. So one thing I do right away is at the 100 mark, I remember that everything before 100 is usually like the SP3 configuration, and everything after the 100 is the SP2 configuration. So we have 9, 38, and 50 ppms. This just tells me that I have some SP3Cs involved. My biggest takeaway are these two numbers right here. These right here, the spikes are between like 128 to 138, which showed me that I had some C double bonds or I had a benzene ring, which goes with the C double bond. This right here kind of cemented the fact that I had a carbonyl carbon connected to an O. So that right there it's already painting a picture that I have a C double bond into an O somewhere, maybe connected to this benzene ring, which has all of these double bond Cs. So next, I used, again, the same sheet to then use for the H1 NMR spectrum, which is right here. And here, this right here, everything below 4 basically just tells me that I have SP3 Cs and Hs, which makes sense. And then here was my biggest takeaway that kind of cemented the fact that I probably had a benzene ring. And it's because I had 5 Hs and they're all singlets. So that this table right here, besides the other two kind of giving me a clue as to what I had when it came to the outside structures, this, or I should say the structure in general, this told me exactly how to build it. So this is my favorite one. So anyhow, next page, I have kind of the tables explaining everything, and it helped put everything into perspective. It also, I'll talk about this later, but it also is where I did this degree of unsaturation formula. So the formula, I keep doing this, I keep forgetting to fix this. So this is an N. So the formula is 2 carbon plus 2, which is the 2N plus 2, plus the nitrogen minus hydrogen minus X stands for halogens. So in this formula, I have 2 and 10 for carbon plus 2, which ends up being 22, minus 0 minus 12, so that's the hydrogen. And all of this equals to 10 divided by 2 means that I have 5 degrees of unsaturation. So anyhow, using this sheet right here was what helped me figure out exactly how to draw my structure. So right away, like I said, at the 7.3, I found the 5 H's, which actually fits perfectly for my benzene ring because I have these 5 H's right here. And then I have a 2H, which is next to it. So then I had this right here with the CH2, and then connected, I also knew that I had a 2H or sorry, a CH2 that's a quartet, which told me that I was connected to a C3 and just connected to a C3. So I knew that these were this CH2 and this CH2 were disconnected, and like this right here was just connected. So this CH3 right here, which is tertiary, was just going to be connected to a CH2, which shows me right here. Sorry, I keep saying tertiary. It's triplet. So the CH3 was going to be connected to CH2, which is what it is in this structure. So I knew these couldn't be together, which then told me that the O was probably in the middle to keep this a singlet. Sorry. To keep this a singlet, just because this is connected to the benzene ring, which is another C, and this is connected to the carbonyl carbon here, which will give you that single spike. And then here we have the quartet because it's connected to the CH3, and then this has the triplet. This right here has a triplet because it's just connected to the CH, which is what shows us in the paperwork. So this is the structure that I propose. It's a benzene ring connected to this little branch here. So it actually is the molecular formula that was given in the beginning, which is the C10H12O, because right here, when I count them out, I have the 6 carbons here, 7, 8, 9, and 10. And then for hydrogen, I have the 5 here, 7, 9, and 12. And then this is the single O. For degrees of unsaturation, the benzene ring gives me 4 because I have the 3 double bonds, and the fact that the benzene ring alone is another one is 4. And then this is the 5th degree of unsaturation, which is the double bond to the O. And that is how I came up with my proposed structure. Thank you.